Another question involving magnetic field. The diagram shows an electric circuit in a magnetic field directed into the page. Okay, the graph shows how the flux through the conductive loop changes over a period of 12 seconds. So you can see here starts off at zero flux. Now don't forget that flux is magnetic field times area. The area is constant, so therefore magnetic field is the only thing that's changing. So the magnetic field or magnetic flux goes up to 0.6, stays at 0.6, and then crashes back down to 0 in 2 seconds, as opposed to taking 6 seconds to get up to here. Okay, so this is the greater rate of change. So calculate the maximum magnetic field strength within the stationary loop during the 12-second interval. So if the loop's sitting up here, then flux equals BA. So flux is 0.6 Weber equals B times by A, which is pi R squared. So that's 0.6 equals B times by pi times by radius, which is 0.3 meters squared. Divide everything out and you get B equals 2.12 Tesla. Righto, next part asks, calculate the maximum voltage. Okay, so maximum voltage is EMF equals negative N change in flux over change in time. And we've only got one loop, so we're good with that. Indicate the polarity of the terminals as well. Okay, so the biggest EMF is going to be when this changes the most, or when the gradient's the steepest. So the gradient, where it's the steepest, is in here. So for that, we get rise over run equals, it runs rises negative 0.6 and it runs for 2. So that's equal to negative 0.3 volts. But because we have a negative, let me just move my page down a little bit. Because EMF equals negative change in flux over change in time, then that's equal to negative N times by negative 0.3 volts, which is equal to 0.3 volts because N, we said, was equal to 1. Righto, so if that's the case, what is the direction of current flow? Once again, at that time, if the circle is coming out of, so let's do a quick diagram. If the circle's coming out of the magnetic field, it's going to want to increase the magnetic field going through it. So in that case, if you use your right-hand grip rule, put your fingers in because it wants to actually have the magnetic field going into the page, curl your fingers around, and we're going clockwise, which is P to Q, P to Q, which must mean that P is positive and Q is negative.